Okay, so now the next thing we should talk about is functions because that's something fairly useful.
Hmm.
So how would we go about creating a function in Swift and calling that function?
Yeah, so to define a function, you use the keyword func, not very creative, uh, and then the function name, transmogrify, and the parameter list. So in this case, we're going to transmogrify between species. So you want to put in a certain species, spe- species,
Yes, that's right. Add an S at the end.
species, uh, and you have to specify its type since there's nothing to infer, and this will be a string. And then you put brackets to have its declaration. But for a return value, there's this arrow operator, and you would put in the type that it returns, which in this case is a string, which is a different species. Yeah, so this is the function signature, defines
Okay.
the input, which is species, the function name transmogrify, and the return value, which is a string. So here we would return everything currently turns into human. So this function, all it does is transmogrify whatever you give it to a human. And to call it, you simply pass it in. So we call transmogrify, pass in like duck. And guess what? It returns a human because that's
Okay.
our rudimentary transmogrifier we have.
Okay, so now if you wanted to make it a bit more complex, let's say if it's I don't know what you've set up a more complex example. So let's make it from string to an int, so we
Sure.
can maybe provide an integer index of the kind of species that is being provided
No,
into.
that's very interesting because we need to index our species, so we have a nice
Exactly,
sort of
for the alien takeover.
exactly sort of.
Okay, so in this case, I think what might be useful is something like a switch statement. So
Mm-hmm.
depending on the kind of species that's provided in the input, we then return a certain integer output.
So we haven't talked about switch statements yet. Switch statements in Swift are very much like other switch statements, except that they are very powerful. They're extremely powerful. Normally, in most languages, you might not be able to switch on strings because strings have special compare
Mm-hmm.
methods.
Right.
But in Swift, that is not a problem at all. So we put in the species, yeah, and put the brackets. And right, we cannot return human anymore because that's a
String.
string. So
Right.
let's change that to 0 for now. So here, and then you put the case, and you can try to put this type in, ducks are species 0. And then let's have a few more.
Now, can you just put 0, or do we have to say return 0?
You're right, we have to say return 0 to get out of the switch statement. And if it's a human, we are species 1. And there is some sort of error, which means I totally missed something.
What about the default case?
Yeah, so in other languages, again, this would be okay. But in Swift, switch statements must be exhaustive. They must cover all cases or have a default case. So what about the default? What should default?
Let's return -1.
-1 will be the default. In that case, we don't even need this anymore because it never gets there. And our transmogrify on the duck returns 0 like it should. But let's call it again for human.
1, and then let's
1.
call it again for cows.
And let's call it again for cows.
You should get -1.
And it's -1. So
now, one thing is, inside the switch statement, if you wanted to have a more complex operation, we could just put brackets here, right? Can we have a more complex?
you don't need to. You really should put it on the next line. So you can, yes, you can directly just
You can just directly type in
Yeah.
here,
inside the
and
case.
so it would just perform all those until before the next case statement.
Yeah, so in Swift, switch statement cases do not fall through. So if we didn't return or break, it would still not go into human, unlike in C and C++ and Java and other languages. You could, however, let it fall through using a fall through command.
I see. And if you wanted to provide an extra bracket, right, within
Mhm.
one of my brackets, is that something that is? I know in C that's normally allowed, but in Swift, is that something that you can actually add these brackets, or is that generally?
I
Guess
believe,
from all the
I
errors.
guess not, because you're getting an error. your brace block of statements is an unused closure, right? Because in Swift, and we haven't gotten to this yet, but brackets actually define a closure, which is a function, so an unnamed function. So right now, this is actually you're defining a function, which would return 0, and you're not using it or assigning it to anything or calling it, so it'd complain that it's useless. Basically, this code is bad. So you can't use brackets as sort of just pure scoping, as you might do in other languages.
So something to keep in mind if you're very much used to C or C++ on that note. Great, so that's a function that has one variable being passed in and one string being passed in and an integer coming out. But what if we wanted to provide now 2 strings going in? Things become a bit more complex in this case.
Yeah, this is just a tiny bit more. So say, I mean, of course, species and their color are all very important attributes. So the color could be also a string. Or maybe we should think of something with a different type, like maybe
let's say weight, and we'll define it as an integer.
We'll do a weight of an integer. So now this takes in 2 variables and still gives out, returns the integer. It's not called transmogrify anymore, really. It's more called index of species.
Sure.
So I'll change all these.
Okay.
And now it's sort of different. So maybe we want to multiply the weight in, or...
So what we can do is we can say the index number that we have is essentially the times 100 plus the weight in kilograms. So if you're a 50 kilogram human, you would be a 150 indexed species.
Sure. So it would be it would be 100 plus the weight. Well, depending on your species, it will be a different formula.
So the example, of course, doesn't matter, but it would be 0 plus the weight here.
Yep.
Gotta spell that right. This would be 100 plus the weight, and the default would be -1 plus the weight, -100 plus the weight. So something like that. Just
Sounds good. And we have a bunch of errors here, which is because we haven't passed in the weight.
Right.
Now that it expects it. So there's actually 2 solutions here. One is you can give a default value of the weight, which is a cool feature. So if you do equals 0 here, that allows you to either pass the weight or not.
Okay.
And if you don't, it takes on this default. So
which is very useful.
Yeah, it's very, very useful.
And you can see right off the bat on the right side, you can see that it's now printing 0, 100, -100 because the weight that being passed in is effectively 0.
Is effectively 0, yes. But if we do want to add a weight, so we have like a extremely oversized duck. Well, we didn't really give units. So
kilograms, but let's make it oversized.
So we have like a 10 kilogram duck. You can also do that. And now you'll see that, now you'll see that there's an error because in Swift, variables actually have labels. Variable names. So you'll actually have to call it.
The weight is 10. You have to directly say that it is the weight, which is interesting because we didn't have to do it for the first parameter. But for every subsequent parameter, you have to provide the name of that parameter.
Yes, the first parameter is the special case here, and it's sort of due to historical reasons and how Objective-C does things, which you will touch upon in the future. But yes, any subsequent parameter, you'll have to give the name of the parameter, which is actually very useful because just by looking at this, you know what this means. Instead of without that, it's like duck 10, but now it's a duck of weight 10, which is very clear. And equally, we can have a normally weighted human, 70 kilograms. And you'll see our
numbers are changing based on that. Let's have a 95 kilogram cow.
A very light cow.
Is that a light cow? I guess.
I think it's a light cow.
Okay, so that's -100 plus 95, which is -5. So why don't we need the index for the first, or can we put the index for the first parameter being passed in?
So if you really want to, you can name the parameter. Say you can, for each parameter, you can give an outside name and an inside name. For example, here, so the outside name might not be species. It might be, we'll call it species. And now there's an error here. What does it say? You're missing the label species in the call. So now you have to add it in.
I see.
So if you really want to make things a bit more clear, if it makes sense, you can do this. And it can also be different. So it can be called name. And we get errors again. Why? Because our label's wrong. So now it has to be name. But inside the function, it's still species. So there's sort of
Okay.
the outside name and the inside name.
Which is a bit perplexing,
Mhm.
but I guess the reason that it's been done this way, which is the function effectively treats the first variable a little differently, the first parameter, than the rest.
Not particularly. So the only special case is that by default, you don't need it. For the second parameter, you can also specify two names for it, and so on. It's really just for readability, because sometimes it makes sense internally. It's called weight, but externally you might want to call it weight in kilograms, for example, or something else that might be more descriptive. It's just really for clarity.
Okay.